This is the Math 7 study guide talking about transformations. Essentially, the four types of transformations are translations, rotations, reflections, and dilations. We'll talk about each of them. Number one, talks about dilating the rectangle by using a scale factor of 1/2. Dilating means to get bigger or smaller. If you read the full question, we don't have to do all the work. It says after the dilation, what's the new coordinates of point M, M prime? We could do all the coordinates. This is the coordinate 1 up 2. Sorry, left 1 up 2. This is the coordinate left 1, 1, 2, 3, 4, 5, 6. Left 1 up 6. 1, 2, 3, left 4 up 2. And left 4 up 6 is coordinate M. Now we could do all of them, dilate by a scale factor of 1/2. That essentially means just multiply all of them by 1/2, -1/2, 1, -1/2, 3. But I'm doing all this work when I don't have to. I just want to know what M is going to be. M is now going to be half of -4 is -2, half of 6 is 3. That's the new coordinate of point M prime. So I did all of them, but I just had to do this point up there. They should read the directions. Question 2 says to rotate the triangle 180 degrees, and what is the coordinate of the new spot B? When I rotate this 180 degrees, I actually have some work to do. So what I'm going to do is I can't do it on this PDF, but I can take it here and rotate this 180 degrees. So rotate 180 degrees means it would go upside down. Right now your paper would be upside down. Let's find the coordinate of this spot B. Almost going to close our eyes. We have to close our eyes. Pretend, start over. This goes to the left, 1, 2, 3, 4. Down, left 4. And let's see how far down it goes. 1, 2, 3, 4, 5, 6. So left 4, down 6 is the new coordinate for point B, or B prime, after I rotate 180 degrees. That's what it would look like if I were able to rotate this paper. Number 3 says to use the 4 grids to model the 4 types of transformations. You can do whatever you want. A reflection would be, well, it depends on what axis you're going through. Things to keep in mind, whatever shape you do, if I reflect it, make sure it's backwards, but more importantly, the same size, but also the same distance away from the axis. So if you're going to do a reflection through the x-axis, it's got to be one way. It can't be one way on this side and 2 way on that side. It's got to be the same distance away. Again, this would not be an okay reflection because it's close here and far away there. It's got to be the same distance away. A translation is a slide. It's nice. You can just have a shape and the same shape someplace else. It could even be over here, slide that way. Just make sure it's the same size. Just kind of split. Dilation gets bigger or smaller. So we can have a, let's say the number 8, and then it's just a bigger number 8 a little bit further away. They just get bigger and smaller, bigger as you go away from the origin. And a rotation. Rotation, let's say I had a shape like this, big long one. If I rotated to this one, it would move slightly on its side. I want to make sure I'm doing this correctly, accurately. It would be something like this. Kind of rotate to the side, same distance away, kind of rotates over that way. Kind of goes sideways when it rotates. Something to keep in mind, goes sideways. Sometimes if you do things you can't tell if it's a reflection, translation, or rotation. Could be multiple ones. You don't know unless you have more instructions. We'll deal with those sort of situations later. So, well, let me put it this way. If I did a rotation, a full 180 rotation down here, it would end up over here. And you might say, oh yeah, that's a 180 rotation. Well, it's also just a translation, also just slip. It's hard to tell sometimes what it is. I prefer to do this so I know it's a rotation for sure. This one we know is a translation, but if I did this, you could say, well, is that a translation or is that a reflection? It's hard to really say sometimes. Number 4 is asking us to take this shape, right here, this triangle, and do 4 different new shapes in them. When I'm done with my shape, I'm going to label the inside of it A, then label it B, label it C, and label it D. So I'm going to start this original. This is my original. We'll call it O for the original. Start with that guy each time. All right, so it's to rotate 180 degrees. Again, to rotate 180 degrees, I can't do it on this paper. You would rotate your paper, but I need to do some work because I can't rotate the PDF. So I just took a picture of it, and I'm going to now paste, take this shape, rotate this 180 degrees, and now I have to write down these coordinates, so that way I can use them. This is the coordinate 0, down 2, 0, down 2. Remember, we're restarting. To the right 2, down 2. Don't think, well, wait a minute, this is negatives. Again, ignore these numbers. You're closing your eyes, pretending and starting over. This goes to the right 2, down 2, right 2, down 2. This spot to the right 2, that's a negative. Again, we're playing pretend. To the right 2, down 1, 2, 3, 4, down 4. These are the coordinates that are going to get me my answer. So 0, negative 2, 0, negative 2, 2, negative 2, 2, negative 2, and 2, negative 4. 2, down 4. This is my shape that I just made. This is A. Well, let's do B. Starting with my original again. B. So to translate 4, 0. We know the 4 is left, right. So what this means is left 4, up / down 0. Left 4. Each of these corners goes to the left 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is my new triangle. We'll label this B. C. Says to reflect over the x-axis. So I'm going through the x-axis, and I'm going through the x-axis. This is my x-axis. I'm going through the x-axis. Don't think, oh, the x goes left and right. And no, we're going through the x-axis. So start each coordinate. 1, 2, 3, 4 to the mirror. 1, 2, 3, 4 away from the mirror. 1, 2 to the mirror. 1, 2 away from the mirror. 1, 2 to the mirror. 1, 2 away from the mirror. This upside down is C. Let's start over with the original again, and we're going to do D. Dilate by a scale factor of 1/2. Now, in order to do this one, we do have to write down our coordinates. This is the coordinate left, right, 0, up 2. Left, right, 0, up 2. There's left 2, up 2. And there's left 2, up 4. It's a dilate by a scale factor of 1/2. It's pretty easy. We just multiply all of them by 1/2. Half of 0 is 0. Half of 2 is 1. Half of negative 2 is negative 1. Half of 2 is 1. Half of negative 2 is negative 1. Half of 4 is 2. Now I just graph these points. 0, 1. Negative 1, up 1. Negative 1, up 2. And this is, because that was by a scale factor of 1/2, so it's 1/2. Actually, the corner is big, but that's besides the point. All the points are multiplied by 1/2. So these should be your 4 shapes. 5 is going to be done the same way as 4. I have 4 transformations to do on this original shape. I'm going to pay attention to this original every single time. I'm going to start over at O or the original. In order for me to do A, which is rotation, I can't do it in PDF, so I have to do a little bit of work. I just took a picture of it. I'm going to paste it right here. Now, it says to do a 90 degrees counterclockwise rotation. So I'm going to take this, I'm going to rotate it. This is counterclockwise. This is clockwise. I want to go 90 degrees counterclockwise. So the opposite of the way a clock works, it should rotate up to the first quadrant. So these coordinates, again, you need to close your eyes, start over, pretend if you need to. We're going to write down these coordinates. This is to the right 1, up 1. You might say that's a negative. Again, we're starting over. This is to the right 1, up 1. This is to the right 2, up 1. This is to the right 1, up 1, 2, 3. And this is to the right 2, up 1, 2, 3. Those are my 4 new coordinates. I'm going to graph these 4 coordinates on this. 1, 1. 1, 1. 2, 1. 2, 1. 1, 3. 1, up 3. And you can probably tell it's going to be right there, but it is 2, 3. 2, up 3. This is my rotated 90 degrees counterclockwise shape. This is A, so I'm going to label it A. B. So it's to translate -4, -2, which means it goes left 4 and then down 2. Or horizontally -4, vertically -2. So it has two instructions. All the points move the same. Make sure you remember you're starting not from the origin, you're starting from the 4 corners. Each point is going to move left 4, down 2. So I'll do left 4, down 2 for all 4 corners. Left 4, 1, 2, 3, 4, down 1, 2. Done with that. 1, 2, 3, 4, 1, 2. Again, moving from here. 1, 2, 3, 4, 1, 2. And this one, 1, 2, 3, 4, 1, 2. This whole shape is moved left 4, down 2. This is B. C. Says to reflect over the y-axis. I know that y goes up and down, but going back to my original, I'm going through the y-axis and I'm going through the y. I'm going into the third quadrant. The y-axis is my mirror. This is my mirror. That's what I'm going to. So each corner has to go to the mirror. 1 to the mirror, 1 away from the mirror. 1 to the mirror, 1 away from the mirror. 1, 2, 3 to the mirror, 1, 2, 3 away from the mirror. 1, 2, 3 to the mirror, 1, 2, 3 away from the mirror. This is my new shape C. Now you look at that and you go, well, was that a translation or a reflection? Now it easily could have been a slide. So you have to be careful that if I didn't know any better, if I didn't know that I was reflecting, I could say it's a translation. That's correct, but it easily could be a translation also. Let's do the last example, which is a dilation. In order to do a dilation, I got to go back to my original, write down these coordinates. This is the coordinate, right 1, down 1. This is the coordinate, right 1, down 2. This is the coordinate, right 3, down 1, and right 3, down 2. If I'm dilating by a scale factor of -2, that means every single coordinate just get multiplied by a -2. -2 times 1, -2. -1 times -2 is a +2. -1 times -2, -2. -2 times -2 is a +4. 3 times -2, -6. -1 times -2 is a +2. 3 times -2 is -6. -2 times -2 is +4. Let's graph these now. Left 2, up 2. Left 2, up 4. Left 4, 5, 6. Up 2, and left 6, up 4. Unfortunately, I kind of worked into my own space right here. But this is what my shape looks like. It's coordinate, not O, sorry. O is the original. D, it's a little bit bigger on the other side, actually 4 times as big. It says to examine the transformation below. Sam thinks rotation. Ben thinks translation. Freddie reflection. Juan dilation. Who do you support? Write a paragraph completely explaining your decision. Make sure you use whole words. So the question is, which of them is it? Is it a rotation? Is it a translation? Is it a reflection? Or is it a dilation? Or could it be more than one? Let's take a look at it and see what it says, see what it shows. All right, so this one, let's deal with each one. Is it a translation? Could it have just slid? Sure, it could have just slid right down. This would be a slide of from here to this corner, goes down 1, 2, 3. So this could have been a slide of 0, left, right, down 3. It could have been a translation. That's correct. Or it could have said vertically -3. It is a translation. Could it be a reflection? Do a different color. Could it be a reflection? It sure could. It's a reflection through the x-axis. This would be this corner then. 1 to the mirror, 1 away from the mirror. 1, 2 to the mirror, 1, 2 away from the mirror. So it could be a reflection. Reflection through the x-axis. So yes, it could be a reflection. Could it be a rotation? Now this you'd actually have to rotate the paper, but if you were to rotate the paper from this way to this way, or even this way to this way, we don't know which one the original is, it could be a rotation of 90 degrees, depending on which was the original. Again, if it goes A to B, that would be 90 degrees counterclockwise. If it was B to A, it'd be 90 degrees clockwise. Will they always be a rotation? Not necessarily. You have to be careful with things like that. If you have one that looks like this, and then there's one over here like this, is that a rotation? No, because in order for this to rotate, when this rotates this way, it ends up standing up. So this would be not a rotation if it was a big, long one. But since we're dealing with squares, if you turn a square to the side, it's still a rotation. So rotations are tricky. And then lastly, is it a dilation? In other words, it got bigger or smaller. Now, technically, there's a dilation where it stays here. There's a dilation of -1 where it moves to the opposite side. But it did not move to the opposite quadrant. You can't dilate and move over an adjacent quadrant. So is it a dilation? The answer is no, it is not. Again, you can have a dilation where you stay in the exact same spot, or you go to the exact opposite side. That's a dilation of -1. But in this case, you can't just move over an adjacent quadrant. It is not a dilation. So it is a reflection, it is a rotation, it is a translation, it is not a dilation.